Hello everyone, welcome to Concept Bites with Shweta. This is where we discuss the most troublesome concepts in bite-sized pieces. Either I choose a topic based on what I've seen students struggle with in my 11 plus years of experience, or you choose a topic. Simply comment the concept that you would like to see explained. Today we have a request about set theory, specifically three overlapping sets formula. So there's confusion about when to use which formula, what is the derivation, what is the logic. So let's get right in. First, you need to understand this a Venn diagram where you see three sets all represented together. Now, there are some important areas you need to understand. So, when you see 1, 2, and 3, these are three regions in which you will have those elements that belong to exactly one set. So, 1, for example, this here is only set A. Same way, 2 is only set B and 3 is only set C. Nothing else at all. Then, if we talk about 4, 5, 6, what is special about these three? All of the elements in 4, 5, 6 belong to exactly two sets. I'll just put exactly here, valid for all of these. So when you look at 4, these elements belong to only A and C, not to B. 5, only A and B, and 6, only B and C. Then what about 7? These belong to all three sets, A, B, and C. And finally, 8, region 8, these are the elements that belong to none of these three sets. Not in A, not in B, not in C. We have to understand this idea of belonging to exactly one or two or three sets or belonging to none of those. Now, confusion comes in the fact that there are two different formulas that we can use. People are confused when do I use which one? But you see the way I've structured it, it is trying to show you that everything depends on the given information. What is given will decide which formula you use. I'm going to explain both to you, so we'll go into them one by one. Say we only look at the at least two situation. What is at least two? At least two means two or more. So in our case, if it's sets, then two or three sets. I'll tell you what this really means. We'll try to visualize the whole thing here in the formula and in the Venn diagram together. There you go. So we are trying to find the total number of elements. What's total? That's all the elements in this entire universal set. Now see, the first part of the formula is A plus B plus C. So when you add A, B, C, it's not saying only A, only B, only C. So it is not talking about just 1, 2, 3. Actually, you end up adding everything. When you add A, you're adding 1, 4, 5, 7. When you add B, you're taking 2, 5, 6, 7. And with C, you're taking 3, 4, 6, 7. A lot of the stuff here is being double counted. Especially, you see, this 5 here, because it belonged to two sets, it got added twice. Same way, the 4 here, this region belonged to two sets. That's why it got added twice. And 6 also got added twice. Also, notice that you've counted this all three region 3 times. You had it in A also, in B also, and C also. So while 4, 5, 6 got counted 2 times, 7 got counted 3 times. This is all your extra counting. So you need to get rid of those. Now look how the subtraction in the formula will slowly help you get rid of this. So first thing being subtracted is A and B. Is it only A and B? No, it's A and B, which means it is subtracting region 5 and region 7. Same way, A and C is subtracting everything that A and C have in common. So you're getting rid of 4 and 7. Finally, B and C means when you subtract that, you're getting rid of 6 and 7. Now you already know 4, 5, and 6 were added twice. So now when I've subtracted them once, I have already taken care of the double counting. So I am in a place where I have not done any extra counting for 4, 5, 6. But observe something. The 7 had gotten added 3 times initially, remember? And now I subtracted it all 3 times. Haven't I lost the all 3 region completely? How do I get it back? By adding it. So I'll have to add region 7 one more time because it completely got eliminated because of these 3 subtractions. And then at the end, you're adding none, the eighth region, because after all, you're talking about total. Had the question been just about the union of the three sets, well, then that would have been this much of the formula. No total, no none. Now, why did I say this is the at least two case? You see, when I talked about all of this information, A and C, A and B, B and C, these, I said they were everything in A and B, including the all three region, or everything in A and C, or B and C, whatever. You were not just looking at those elements that were in exactly two sets. You were instead looking at those elements that were in at least two sets, two or three. So when a question talks about information where they're talking about all those people who like music and dance, and they're not saying only music and dance, it is then this formula. Now, when will you use the other formula? That is where it doesn't talk about at least two. In the question itself, it talks about exactly two. Example, it would say something like only music and dance. So it is talking about two categories only, which is when this formula will make sense. And again, we'll derive this. This is also as simple as the first one. You see, the first part remains the same. When you add A, B, C initially, you have double counted some things. That means you've counted some things two times. What were they? 4, 5, 6. And there are some things that you've counted three times. That was region 7. This time, look at how we're subtracting. We say subtract A and B only. That's region 5. A and C only, that's 4. B and C only, that's 6. So this time when I subtracted, I have taken care of all of the double counting elements. That much is settled. I have not taken care of the 3 additions that I had done of region 7. Not at all. Now, because I've counted them 3 times, I want to count them just 1 time. I will have to subtract this region 2 times. And that's why in the formula here you see 2 times do you subtract region 7. So think about it overall. 3 times you had it, 2 times it went away, you will be left with region 7 also just once. So it does account for every element, finally adding none to get the total overall. Spend some time on both of these again. Try to understand the derivation yourself again, and then look at a couple of questions. The moment you read the question, you'll be able to tell, is it an exactly two situation or is it an at least two situation? Once you learn how to differentiate between the two, no question again is going to be difficult. I hope this helped. Happy learning. Let's do it right.